Marco.
Whoa, hey, how are you, Jordan?
Hey, what are you doing right now?
I am taking a poop and reading a Lakers magazine.
Interesting. I was just wondering if you're ready for the physics test tomorrow.
There's a physics test tomorrow?
Yeah, I think it's about Newton something. I don't know.
You think you can help me out on that?
I never pay attention.
Hey guys, do you want to learn about Newton's first, second, and third law of motion?
Yeah, we do!
Let's do it!
Okay, so here's an example of Newton's first law. So what Newton states in his first law is that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon an imbalanced force. In this example, we place a tablecloth on a flat surface table with two equally heavy cups. Christian then grabbed one end of the tablecloth and pulled it at such a fast speed that both cups stayed put in the same place. If we were to pull the tablecloth at a slower speed, the stationary objects would have gone in the same direction and speed as the tablecloth. It would look something like this.
That was worse. That was faster though.
Hey, Marco.
Whoa, hey, how are you again?
Good. I was just shooting some people. How are you doing?
I'm kind of stressing about the second law. Do you know it?
Well, did you learn the first one?
Yeah, Jeannie Cuba taught me it, but I do not know the second one.
I think we should call it Genie Cuban.
Good idea.
Ham and rice, ham and rice.
Hey guys, are you ready for Newton's second law of motion?
Are we ever?
Yeah! Let's do it!
Oh,
Hello.
how are you again?
I'm always ready. How are you?
I'm good. Are you ready for this lesson?
Am I ever? But where's Genie?
Here I am, Sir Ferguson's.
Where?
I cannot see you.
I'm everywhere.
Creepy.
So, kids, Newton's second law of motion states that the relationship between an object's mass, m, its acceleration, a, and the applied force, F, is F equals m times a. Therefore, this means that the result of the force equals mass times acceleration. Also, acceleration and force are vectors. Therefore, they have the same direction. So guys, you ready to try this experiment?
Yes, we are.
So, you just need a big car and a small car.
Well, I always have my big car.
And I got my small car.
So, let's do it.
So how are we gonna do it?
Well, you just need the big car and small car, and you're gonna put them on the skateboard.
Okay.
Therefore, you have to put them on the same exact point, and they will have the same acceleration, but different mass.
Sounds good to me.
So Marco, you're up.
Good luck, bro.
Okay, so it didn't reach that far. Let's do it with the big car.
I'm gonna destroy you.
Okay.
Okay.
Whatever makes you sleep. Okay guys, so let's do the same experiment, but now let's change the acceleration. We can have the same masses as in the first experiment, but let's change the acceleration. Tell me how we could do that.
I would guess that by increasing the vertical height.
Exactly. So that's why you set up that chair, right?
Yes.
Okay, let's do it. Let's see if it changes the results.
Whoa, it went farther this time.
Exactly. Okay, JD, now it's your turn to do the experiment.
Can you help me out, Marco?
Of course I can.
What did you learn?
Whoa, Genie. I learned that force equals mass times acceleration. And when we compared the two cars, that meant that the one with the greater mass pushed the Jenga piece farther because it had a bigger force.
Oh, interesting.
What did you learn?
Well, I learned that when there is greater acceleration, there is greater force, and we showed that in the first and second trial because in the first one, the surface was flat with a skateboard and the acceleration was lower than the one when we increased the vertical height. So when we increased the vertical height, there was greater acceleration, therefore there was greater force exerted onto the Jenga piece, and it flew farther.
That's correct, sir.
Genie Cuban, can we see you now? Where are you?
It depends on the consequences. Wait.
Can you appear? Are you gonna appear, Genie Cuban?
Hello, guys.
Oh!
How's it, Marco?
Whoa! Hey there, yeah, Jordan.
I was just wondering, how are you doing with the third law?
Oh man, I forgot about the third law. I didn't study it. We need Genie Cuban again.
And rise, and rise.
Hey guys!
Whoa!
Are you ready to learn Newton's third law of motion?
Yes, we are.
Go on! Let's do it!
Now, let's talk about the third law. Here, Christian and Marco each took giant plastic balls and ran at each other at the same pace. Newton's third law states that for every action, there is an equal and opposite reaction. So when both balls collided, the force exerted onto the balls was returned onto both Christian and Marco. When Marco ran against Christian, Christian was pushed by his force because you can only return as much force as you can have.
Have a good day.
Oh, hey, Marco.
How are you again?
I'm great. How are you doing?
What was you doing?
It's just the body. How was your test?
I think I did pretty good. How did you do?
Me too. We can only thank one person,
And that is
Genie Cuban.
Hey! You know it, guys! Anytime you need help, just call Genie Cuban. Ham and rise!
Let the bass kick.
I'm talking Vegas, Miami, New York, LA, Japan, out in London, ATL, Chi-Town. I know you understand. Put your fucking hands up, up, up.
Marco, how are you doing today?
I'm fine, thank you. How are you doing?
Have you heard about Newton's laws?
I kind of heard it.
Newton's laws? How are you? Are you ready for the test tomorrow?
There's a test tomorrow?
Yeah, in physics. I think it's about Newton something.
Do you think you can help me out on that?
Hey guys! Do you want
It's fucking
hilarious.
Marco.
Are you ready for the test tomorrow?
Hey, how are you? Yeah, what test?
The physics test tomorrow about Newton something. I'm not even ready for it.
I don't know. Do you think you can help me out?
Hey guys! Oh, what is perfect.
I'll help you though.
Okay.
Try to hit it.
Oh.
I wanna be the very best, like no one ever was. To learn them is my real test, to train them is my cause. I will travel all across the land, searching far and wide. Each Newton's law to understand the power that's inside. It's you and me. I know it's my destiny. Newton's laws. Oh, you're my best friend. In a world we must defend. Newton's laws. Our heart told to the You teach me and I'll teach you. Newton's laws.